So this Fourier transform infrared actually uses infrared principles to tell us the kind of organic compounds we have.
Online.
Hello?
Someone is online.
Okay, I've not seen the person.
Okay, the person is in already.
All right, yeah. Okay. So FTIR, assists us in knowing whether there's a carbon-hydrogen bond, carbon-oxygen bond, oxygen-hydrogen bond in a solute that is dissolved in that water. So what it means is that if we dissolve some kind of things like detergents or oil or whatever in water, with FTIR, we can have an idea of the kind of functional groups that are in solution. And by the spectra that comes out, we are able to, work out and know that this is what we have. And then we start designing a method to quantify the amount of those solutes that are present in solution. So this is how an FTIR machine looks like. Very simple. So this is where you put the okay, let me admit Chinedu in. Chinedu, you're welcome. So we put the water sample there, we close the chamber on the machine, and then the machine reads for us what we have in solution. So the kind of reading you're going to see is what we have here. All this is zigzag, zigzag, and it goes from a wave number of 4,000 to 500. You can see the descent and the ascent and the signature that we have here. So the troughs and the peaks that we have here, at what point do we have this trough is at about 1,750. What are the functional groups that used to show at this place? It will tell us the kind of organic compound that are inside that water. Then we come to this peak that is here. This peak is about 1,200. Okay? And then we can compare this with an ideal peak to see what we have. So the knowledge of this one is for us to go deeper into on another day. But we need us to know that Fourier transform infrared spectra, this is how it comes out. You have a transmittance on the y-axis, and you have the wave number on the x-axis. And based on what is dissolved inside that water, that is what gives us this signature that we have here. And with this signature, we can compare it with some spectra that we have in pharmacopoeia. If you go to the back of your pharmacopoeia, you will see a lot of this kind of spectra there that tells us of the kind of organic compounds that we have in solution. All right, ion chromatography. This one is like HPLC, high pressure liquid chromatography. Ion chromatography is different because it has resins in there that helps us to separate the different solutes that are present in that water. So once they are separated, they can also be quantified. And when that ion chromatography is connected to a conductivity detector, then we have what we call conductivity detection. All those ions that we have, cations or anions, they conduct at different levels and to different degrees. So with that, we can tell what kind of ions are in solution and what is the quantity that we have. And this can be connected to a computer with a software that tells us this is what we have. So these are very interesting things, as it were. So this is the protocol of ion chromatography. Okay, you can see this red triangle signifying calcium ions. You can see this yellow, okay, representing sodium